Welcome to The Explainer. Today, we're diving deep into the world of speech-to-text AI. Our mission is to cut through the noise and help you figure out which models are really leading the pack, and more importantly, how you can pick the absolute right one for what you need to build.
So let's just get right to it. This is the question, isn't it? The one every single developer is asking when they start working with voice. Every week there's a new model, and they all say they're faster, cheaper, more accurate. But is there really one single best AI out there? You know, it's so tempting to see a headline like this and just take it as the final word. And hey, for some specific tasks, it might even be true. But in the AI world, the simple answer is almost never the whole story. The best model isn't some one-size-fits-all magic bullet. It really truly depends on your mission. Okay, let's start with the metric everyone loves to talk about: accuracy. On the surface, it seems pretty simple, right? You just want the model that makes the fewest mistakes. But how we measure those mistakes and which mistakes actually matter, well, that's where things get a lot more interesting.
To measure accuracy, the whole industry pretty much relies on something called word error rate, or WER for short. It's actually a pretty basic formula. It just counts up all the mistakes a model makes: words it adds, words it leaves out, words it gets wrong, and then divides that by the total number of words spoken. Long story short, a lower WER score means a more accurate transcript. Simple enough.
But, and this is a huge but, you have to be really skeptical of those shiny benchmark numbers. A lot of the time, they're created using super clean, perfect, studio-quality audio. The real world, as you know, is messy. It's full of background noise, people talking over each other, thick accents, all the stuff that can make a model's performance just fall off a cliff.
And this is where things get really nuanced. For a lot of apps, like say a customer service bot, getting a slightly lower overall word error rate is way less important than perfectly capturing one single critical detail. Think about it: an email address, a phone number, a product ID. If you miss one dot in that email, the whole thing is useless, even if the overall WER barely even budged.
So yeah, while models from OpenAI like GPT-4o and Whisper consistently crush it on these clean audio benchmarks, the point you have to remember is that this is only one piece of a much, much bigger puzzle. Raw accuracy is not the only thing that matters, not by a long shot.
All right, so we've talked accuracy. Now let's pivot to dimension number 2, speed. Because for a massive number of modern apps, how fast you get the transcript can be even more important than it being 100% perfect.
Just think about any kind of interactive app, a voice agent, live captions for a meeting. The whole experience lives or dies by the speed of this pipeline. Every single step adds a little bit of delay, and that speech-to-text model, that's the very first bottleneck. If it's slow, the whole thing just feels laggy and broken.
It turns out we humans are super sensitive to this stuff. Studies show that any delay over about 200 milliseconds, and the conversation just starts to feel unnatural, awkward. That's exactly why models like Pulse from Smallest.ai, which are built from the ground up for low latency, are such a game changer for real-time AI. They can fire back a response before others have even finished processing.
And here's a little industry secret for you. Some of the most accurate models we just talked about, like Whisper, weren't even built for this kind of instant back and forth. Nope. They were designed for what's called batch processing, where you give it a whole audio file after it's done recording. Trying to get them to work in real time often means using clever workarounds that can affect their performance.
Okay, accuracy, check. Speed, check. Now for the third, and let's be honest, maybe the most critical factor in this whole framework: cost. Because it doesn't matter how amazing your model is if you can't actually afford to run it at scale.
When you're ready to go live, you've basically got two paths. Path 1, use a managed API from a company like Deepgram or Google. You pay by the minute, but you don't have to worry about any of the hardware. Path 2, host an open source model like Whisper yourself. You don't pay per minute, but you better be ready to invest some serious cash in GPUs and engineering time. And to see just how huge that difference can be, check out this real-world story. The GDELT project needed to transcribe 25 TV channels 24/7. They did the math, and to self-host the open-source Whisper model for that job, the price tag was over $200,000 a year, just for the servers. But then they looked at using a managed Google API that could handle their workload more efficiently. Suddenly, their annual cost for the exact same job plummeted to less than $40,000. It's the perfect example of how free open-source models aren't always the cheapest option in the real world.
Okay, so now that we have our three-part framework:
Accuracy, latency, and cost, let's put it to work and see how it applies to a couple of specialized missions. This is where picking the right tool for the job becomes absolutely essential.
So, mission number 1, building a voice agent. Our framework immediately tells us to prioritize low latency above almost everything else. But it's not just about raw speed. You also need really specific conversational features, like being able to tell the instant a user has stopped talking. Models like Deepgram's Flux actually build this logic right in, which makes the whole process simpler and the conversation feel way more natural.
Now, let's switch gears to a totally different mission. Imagine you're building an app for the massive user base in India, where it's super common for people to mix Hindi and English in the same sentence. For that audience, a generic all-purpose model that was mostly trained on American English might be a complete disaster, no matter what its benchmark WER says.
And this is exactly where a specialized model like SarvamAI's Saras v3 just completely shines. It was built from the ground up, trained on over 1 million hours of actual Indian language audio. And the result? It blows the global giants out of the water on benchmarks that test this kind of real-world code-mixed speech. So, I think you see where this is all going, right? The big takeaway here isn't trying to find the one best model. It's about finding the best model for your specific mission. It is all about understanding these trade-offs between accuracy, latency, and cost.
So let's just put a bow on this. Based on everything we've talked about, if your mission is a real-time voice app, you should probably look at Pulse for its incredible latency. If you're just transcribing clean audio offline and need the absolute highest accuracy, GPT-4o is an amazing choice. If you're building for the Indian market, Saras v3 is the undisputed leader. And if you need a great, balanced, all-around API, Deepgram is a really compelling package.
And that leaves us with one final big question to chew on. As we find ourselves talking more and more to our devices, our cars, our homes, what's actually going to define a good AI conversation in the future? Is it going to be flawless, perfectly punctuated accuracy? Or will we prefer an AI that can keep up with the speed of human thought, even if it messes up a word or two along the way? The answer to that is going to shape everything.